Hey, I'm going to work through some practice problems for the chain rule derivatives here. The first one is f of x equals the fourth root of 1 plus 2x plus x cubed. So the first thing I'm going to do is I'm going to rewrite this thing, f of x, and I'm going to change the fourth root to an exponent. So 1 plus 2x plus x cubed, and raise that to the 1/4. And when I want to take the derivative, I'm going to look for something inside the function. So this looks like a power rule function, something to the 1/4. So I just got to focus on that something inside there. So let's treat it as we normally would a power rule. So derivative would be f prime to bring the 1/4 out front and reduce that exponent down to what, -3/4? Now, the inside part, which we usually think of as the g function, or u, is 1 plus 2x plus x cubed stays inside. And then on the outside, if that's my u or my g, however I want to think about it, let's call it g. On the outside would be the g prime. So we're going to put the derivative of that thing on the outside. So derivative of 1 is 0, derivative of 2x is 2, and the derivative of x cubed is 3x squared. So there we have the setup. If we want to clean that up a little bit, it's not necessary, but I would say we can put the 2 plus 3x squared on top. The 1/4, the 4 part of that will go on the bottom. And then we can have the fourth root of 1 plus 2x plus x cubed down there if we want to. But it gets a little bit messier that way. So let me try and rewrite it just a little bit. Usually I don't try and clean things up, but if you've gone ahead and done it, sometimes it helps you feel good about it. Alright, so now let's see here. Let's go to the next problem. Trying to figure out how to make certain things work. There we go. Let's give ourselves a little bit more room. But this one is g of t equals 1 over the quantity t to the 4th plus 1, and all that is cubed. So I'm going to start by rewriting that. So I'll rewrite it as g of t. And I'm going to bring this cubed part to the top. So we'll have t to the 4th plus 1 all raised to the -3. That lets me use it as a power rule again. If I leave it on the bottom, I'm doing a quotient rule, which I like to avoid if I can. But like I said, it's going to be a power rule, so my t to the 4th plus 1 is on the inside. So that's the part that is kind of like the g or the u. So my derivative will be a power rule. So it's to the -3 power, so bring the -3 out front, and that means the exponent will go down to -4, And with that, we can put our original g or u back in, t to the 4th plus 1, and put the derivative of that on the outside, 4t cubed. And you're welcome to try and clean that up again, like I said. This one won't be so bad. It'll be basically -12t cubed on top, and on the bottom it looks like it will be t to the 4th plus 1 all to the 4. Alright, so hopefully that one works out good for you, but whether you clean up or not is kind of up to you. Let's see here. Let's just highlight the u part. There we go. Alright, let's sneak another one in here, and let's go down the page a little bit. So number 3, f of x equals the natural log of 1 minus 3x. We don't really have to rewrite with this one to start with because we've got the natural log of something, and that something is a little bit more complicated, but we have a rule for that. So we know the derivative of a natural log function is 1 over the function. So derivative will be 1 over this guy, which is 1 minus 3x. But then we'll tack on the derivative of that, which is just -3. So in this case, if you're trying to look at it, this right here, the 1 minus 3x is the g, or the u, and the negative 3 is the derivative of that. So if you want to clean that up, a little bit of that could be negative 3 over 1 minus 3x, or some combination of that. All right, let's sneak another one in here. Number 4. We've got y equals e to the x times cosine of x. Well, nothing wrong with this, because the exponent there, we know the derivative of e to the x is e to the x, but now it's a little bit more complicated, so we're going to have to tack some stuff on. But it will be a little bit more than we're used to. But the derivative will be y prime equals e to this thing, x cosine of x. So that is still our g or our u up there. But then we got to tack on the g prime. And the only thing that's different about this one is the x times cosine of x requires a product rule. So we can let the u be x, we can let the v be cosine of x. So in that case, u prime is 1, v prime derivative of cosine is negative sine. So when we put that back together, uv prime will be negative x sine of x, and then u prime v will be plus cosine of x. So we'll tack this onto the outside of our derivative. I'll rewrite it so it looks a little bit better. Cosine of x minus x sine of x. So there we have the chain rule for the exponent part, and because the exponent was a product, we actually used a product rule in making that happen. So we can't forget all of our old rules either. All right, let's sneak one more on this video. Let's do number 5 here. So number 5 is g of x equals cosine of 5 plus x cubed. We know how to take the derivative of a cosine, so we're in good shape here. We don't have to rewrite anything. And 5 plus x cubed is a little bit more complicated than our x, so let's see here. That would be our g in there, or our u, whichever way you want to think about it. So g prime, our derivative, will be derivative of cosine is negative sine. And we leave our placeholder for the function, and then we'll tack on the derivative at the end. So we'll put our g in here and our g prime at the end. So my g was 5 plus x cubed, and my derivative of that would be 3x squared. So I can very easily see you wanting to rearrange that. No need to, but if you do, you can say negative 3x squared times sine of 5 plus x cubed. Okay, and let me know if you have any questions there. I'll stop this video and pick the rest of them up in a minute.